Hi, welcome back to LeetCode. Today we discuss LeetCode problem 2416. Sum of prefix scores of strings. So you are given an array of words of size n consisting of non-empty strings. We define the score of a string word as the number of strings word I such that word is a prefix of words I. For example, if words is equal to it contain A, AB, ABC, CAB, then the score of AB is 2. Since AB is prefix of both AB and the ABC. So AB is on itself is a prefix of own, and the ABC also you can actually see that the AB also the prefix of that. So that's why the score of AB will be 2. So return an array answer of size n where answer I is the sum of scores of every non-empty prefix of words I. So let's go to the example that will be more clear actually. So this actually our words content. It contains ABC, then AB, then BC, then B, right? So first word ABC. Okay, so what are possible actually prefixes are possible? A, AB, ABC, right? So I have to find out the sum of score of all these prefixes, right? That will be the actual score of the word ABC. So what is actually score of A? So what actually score of a string is like the how many actually string of common prefixes it actually have. So A, how many actually strings are here? How many strings are here? Which is starting with A. One is ABC and one is AB. So the score of it will be 2. Next prefix is AB. So how many strings are here actually? That is starting with AB. Prefixes have actually AB. This string also have AB. This string also have AB. So the score will be 2. Now next prefix are possible is ABC. So how many strings are here in the input array? Or actually prefix is ABC. One string is itself. Any other string with starting ABC? No. So the score will be only 1. So what is the score of this? Ultimately 2 plus 2 plus 1, it will be 5. So the answer array first it will contain 5. Got it? For ABC. Next word is AB. So what are the possible actually prefixes possible A and AB? So how many strings are present in the input array which is starting with A? One is ABC, one is AB. So the score will be 2. Next is AB. So how many strings are in the input which is starting with AB? One string is ABC and another is AB. So the score will be again 2. So what is the total score? 2 plus 2 will be 4. So the answer array it will be actually inserted as 4. Got it? Next is BC. So what is the possible prefix? Possible B and BC. So how many strings are in the input array which is starting with B? One is BC and another is B. Both are starting with B. So the score will be 2. Next, how many strings are here with starting with BC? Only this string BC. So the score will be 1. So ultimate total score is 3. 2 plus 1 is equal to 3. So in the answer it will be 3 will be stored. Next string is actually B. So what are the possible prefix are possible? B, only B, because only one actual character present. So how many strings are in the input array starting with B? B itself 1 and BC. So total 2 strings are starting with B. So that score will be 2. So you can check actually what is the actually answer vector 5, 4, 3, 2. You can also check 5, 4, 3, 2. Now is it clear that how actually got the actually answer 5, 4, 3, 2? Right? So what is the brute force approach? What actually are doing actually? Brute force approach, what actually generate? We have to generate all the possible actually prefixes from each input word. Like for ABC, I will store in the map. Okay. Actually we have to count the frequency, right? Map that I have seen one map A will contain 1. Okay. Then map AB will contain again 1 because first time we are seeing AB. Then map ABC will store 1. First time we are seeing frequency is 1. Okay, this is for ABC. Next is our what is AB. So again I will say A first prefix are possible A. Then I'll say A is stored in the map. Yeah, it's already stored. So I will increase the frequency by 1. So now it is frequency is 2. Next string is next prefix are possible AB. I will check the frequency of the, is it stored in the map already? Yes, AB is already stored, so I will increase the frequency by 1, it will be 2. Now next, I have already processed AB, all prefixes have been stored. Next string are possible is BC, right? Next string is BC. So what is the possible prefixes possible? B and BC. So B will check, have I stored already that B? No. So I'll store in the map that first time I've seen B, so it will be 1. Next I will store BC with frequency 1 because I have not seen BC before that. So frequency will be stored 1. Now next string is B, only B, and prefix are possible B only. So I'll check, have I seen B before? Yes, I have seen that, so I will increase the frequency by 1, it will be currently 2. So you can check this actually ultimate the frequency of each prefixes. Like how many number are starting with A? 2. How many numbers starting with AB? 2. How many number are starting with ABC? 1. How many strings are there starting with B? 2. How many number are there starting with actually BC? 1. Clear? So this is actually ultimate frequency of each prefixes. Now again I will traverse the input string. So first I will get ABC, right? Then I will again generate all the possible actually prefixes. First I will get A. So I'll check what is the ultimate frequency of A. I will got actually 2. So I'll add actually 2. Then next possible actually AB. Next possible prefix AB. So I'll check what is the frequency of that in the map 2. I will add actually 2. Then possible is ABC. I'll check what is the frequency of this in the map 1. Ultimately 1. I have completed all the prefixes, so ultimately this is 5. So I'll store in the array. Next again I will traverse the next word. Next word actually AB. So first of all I will check A. How many actually frequency of the A? This is 2. Next is actually AB. So what is the frequency of AB? 2. So I will add this. So ultimately 4. I have actually completed the iteration of all the prefixes. So it will actually 4. And I will store that in the answer vector. Next actually is next string is actually BC. So I will first check what is the frequency of B in the map 2. So I'll add 2. Next is BC. How many times I have actually seen BC? 1. So this will be 3. So I'll store 3 in the answer vector. Next string is actually B. So what is the possible actually prefixes? B. So what is the frequency of B in the map 2? And I have already completed the all prefixes, generated all the possible prefixes. So this is stored in the answer vector. So I'll store 5, 4, 3, 2. Right? So what is the time of this here actually? Like first of all, we are generating all possible prefixes from input word and all possible input words. So suppose there are a number of words actually n words are possible present in the input array. So length is actually L. So I'll actually for average length actually L for each word. So for length L, I actually traversing and storing all the possible prefixes. Like you can check actually for our input string is actually ABC. First of all, I store in the A, then I'll store AB, then I'll store the ABC, right? So I actually traversing the each character of the input word. So that's why average length is actually L. If length of each word, average length is L. Then if there are n number of actually word are present, then the time slot will be n into L, right? And again we are actually traversing again the input array. Then again we are generating each prefixes. So here actually also time slot will be n cross L, right? But what is the space complexity here actually? Space complexity. This is a time complexity. Space complexity. Like for each, like you can check actually A, AB, ABC. So now you can check actually this actually storing actually like it will actually length is actually L. So first length will be 1, 2, then it will be length L. So time space complexity L into L plus 1 by 2. This is for one word. And if there are n word, then multiply with n. Is it clear how actually we are getting this? Like first for if there is 3 length is 3 ABC. So how many actually word actually I have stored? 3. One for A, one for AB, and one for ABC. So how actually first length is actually 1, next length is actually 2, next length is actually 3, right? Like right. So here actually you can say actually if there is a length is actually L, so we are actually storing L strings. L strings with, if there are n numbers, so the number of actually strings will be n into L. This is the space column total. Like the length of what is actually L, then we generate L number of actually strings. Prefixes are possible. L number of prefixes are possible from, like suppose A, B, C, D. The length actually 4. How many prefixes are possible? One start with A, then AB, then ABC, then ABCD. So there are actually 4 actually prefixes are possible. So that's why the length of the what is the length of the input word, that will be the that many number of actually prefixes are possible. So that's why that many numbers means L length of average word actually length of average length of word is actually L, and there are n number of words are present. So that's why time space only n into L. Can I optimize this more? Yes. How? By using trying. How actually? Now you can check actually. So there is a suppose 2 words are present, A, B, C and A, B, C, D. Okay. Then we have to find out the score. Okay. So how actually trying will help us here? First of all, we have to store the frequency of each, like what actually you're storing before in brute force approach, like in map, like how many actually strings are present. We're starting with A, right? A is starting with B, A2, AB is present 2 times, right? In this way. Here also we are storing the same one, but we're actually not repeating this. How? Like first of all, processing the input string ABC. So I've created a root node. Okay. And how many actually character present? How many character present? A to Z. So 26 character present maximum. A to Z. A, B, C, D. In this actually Z till Z actually 26 character can present in any position. So first of all, I will check in the root node. Okay, there will be 2 fields. One field the frequency of that current, and another for the child of that. If there is any child on this node actually. So frequency, what does it actually indicate here actually? It indicate how many strings are prefix present here. Like how actually I am actually showing you. Like suppose first we want to store ABC. How actually we will store? First I will check, I will come to this root node, whatever the root node. I will check, is there any child node with initially frequency will be 0, because I have not seen any strings with prefix is actually this, whatever the path. So first I will check, is there any node with a child node. I will check, okay, this is actually null. So first of all I create this a new node at the corresponding to A. Okay, you can actually take the vector also, because the size will be 26 fixed also. You can also take the actually map also, like against A I will create a map of a node. Okay, so suppose I have created a node particularly for A, because I want to store A. Now I'll store what is the frequency of this. Frequency will be currently 1. Why? Because I have seen one that ending with prefix ending with A. Okay, now I want to store what? B. Next category is B. So I'll check in this node, is there any child node for B? I have not seen. Okay, there is no child node, so I'll create a new node with B for B. And currently I will see frequency as 1. Why 1? Because I have seen first time actually I have seen this. Next, what I want to store? C. I will for this node I will search, is there any node any child node for C? I will see, okay, there is no child node, I will create this node. Okay, I will create this node for C, and frequency I will store 1. Okay, so I have actually processed my input string ABC. Next our input string is ABCD again. So again from root I will actually start to store. Okay, to store the ABCD. Now what I'll do, I'll for from this root node I'll search is there any child node for A. I'll check, okay, there is already a child node. I will come to this node, I'll point to this node and increase the frequency by 1, because this is my second time actually I'm seeing this. Okay, whatever the count I will increase by 1. Next our character is B again, so I'll check is there any node, child node for B. I'll check, okay, it's already present, so I'll come here, and what is the frequency I will increase that. Okay, next what is the child node? I wanted to store C. I will search is there any child node for C. Yes, already present, so I'll come here. Okay, so I'll come here. Now frequency I will increase by again by 1, so it will be actually 2. Now frequency is 2. Now whatever next category you want to store actually is D. I will check is there any child node for D. I'll check no, so I'll create this new node. Okay, with then I will frequency I will set as 1, because I am creating this and I have to assign this something. So first time we're seeing this, so that's why we're actually assign 1. Okay, so you can check actually this is our trie will look like first it frequency 0, then frequency is 2 for A, then B frequency actually 2 again, for C also frequency is 2, and D is 1. Okay, now come to actually the score method, how actually help us here actually. Now we again actually start with AB. First of all, what do you want to search? A. So under root node I will search how many actually A are present. So this will actually, I have already processed the input strings. Now I will check what is the frequency of that particular node. For the child node A, I will check the frequency is 2. So current score will be, I will add 2. Okay, next I will search for B. Now you can say actually whenever we are actually here, we are actually searching for the prefixes, how many actually AB are present in how many strings. So you can check the frequency actually 2. Again I will actually add this into the score. Next is C, so I'll come here, and what is the frequency of this? 2. So I'll add this, so this will actually 6, right? The score actually 6, so our answer vector I will store 6. Next is actually ABCD. So again I will start from the root, I will search for A, I will come to this node. What is the frequency of this? Frequency is of this 2, right? Next I will come to B, node B. What is the frequency of this? 2. Next I'll come for C. What is the frequency of this? Again 2. I'll come to this node D. Next category is D, ABCD. So frequency, what is the frequency of this? D, 1. What is the score of this? 7. So in the answer vector I will store 7. Now ultimately whenever actually we are actually coming to any node, like here actually, suppose we come to this, so actually we are searching for how many strings are starting with prefix as A, how many starting with whenever I am here actually in this node, I'm actually trying to find how many actually strings are here starting with AB ultimately, because I have already checked A. Now I come to B, whatever the frequency of this actually indicate that how many strings are there starting with AB. Got it? Similarly for whenever I am here, I'm actually trying to search how many actually strings are there actually starting with ABC. Frequency will tell us that, like whenever actually inserting, first it will insert A, B, C. So on each node actually I will actually increase the frequency. That means whenever we are just seeing any new strings starting with that particular string, particular prefixes, so that will be actually indicate here actually frequency for particular prefixes. Got it? So try, I think you all actually got the understood the explanation, right? And logic also, how to try help us here actually, and try how actually it's working. If you like the explanation, please like the video and subscribe the channel if you're not yet subscribed. And if you have any doubt, you can also comment on that. I'll try to always actually explain that. Now come to the code actually, that actually help more actually. So first of all, what I'll do, I'll create a new trie. Then I'll come to actually what is the trie actually, how actually storing. I'll create a new try. Okay, now for each I am iterating the input array words and insert storing this in all words into a try. Now I have to return a vector of integer, that is the answer for each word, actually the score of the each word. So that's why I'm again iterating the words vector. Okay, and whatever the score actually it will return, I'll store this into the answer vector A and return that ultimately. So what actually try actually look like? So for each node, actually I can have actually two things. I will actually have one for frequency, one for the child node, if there is any child node. So frequency means what? How many actually strings are there? We start ending with or starting with A, B, or ending with that, right? So that's why you can say actually there are two things. There is a 26. Why 26? I have taken a vector 26, size 26, because there actually one A to Z actually character can present only. So there's a 26 character. So I have a position 20 to 0 to 25, 0 for A, 1 for B, in this way Z for 25 position wise. I will check ultimately directly go to that 0 index for A. I'll check that okay, 0 index is null, means there is no child node previously. There is no child node for A. So I have to create a new node. If it is already there, 0 index is not null, that means I have already created a new node, just increase the frequency or get the frequency. Okay, so now and CP is the frequency of that. It will store the frequency of the current node. So whenever you are creating a new try node, actually I will actually initializing all the child node as null, because there is a node. I have not seen any child for that node right yet. So that's why I am initializing with null, and the frequency is 0. Okay. Now I have actually called before actually processing that, I actually store all the words in the try. So how I actually store that? It will actually help us actually here actually. First of all, I will point to the root object. It will actually point to the, this means the root node. Now for each word, like I will get the word, like each word actually I will get like A, B, C. So and I'm pointing to the root. Object is pointing to the root. Now for each character, I will just check under root for A, that like how to check that particular position. I have actually indexed this 0 for A. So that's why actually whatever the character A minus A, it will actually give the 0. So I'll check that particular index is equal to null. That means I have not seen any child node for that. So first time actually seeing this, so I'll actually create a new node for that, and I'll create that. Otherwise, then I will come to the here actually. I will just go to the actually that currently I will point here actually, because I have already created a node, and I will come here and I will actually increase the frequency also. I have initialized with 0. This frequency was CP was initially 0, and I have increased to it by 1. Okay. Next I will go to the actually check from this node B minus A, it will return 1. So for one position index 1, I will search that that child node, that object array, that actually that position 1 is equal to null. Yes, it is null. So I'll create a new node again with CP is equal to 0. So I'll come here actually, and I'll actually currently I'm pointing this node, and also frequency will be increased by 1. Next, this is for B. Next I will search for C. So this is for 0, 1, 2. So 2 is for C. I'll check that index 2 is actually null or not. If it is null, it is yes, it is initially null. So I'll create a new node again, okay, with CP is equal to 0, and all the child node will be null. So I'll just now point to here, and I will increase the CP by 1. Now you can check I have actually stored ABC first time. Next time whenever I say ABCD, input string is again ABCD, because it will call for each word, right? Iteratively we are calling this for loop. So now our input string is ABCD. Now I'm again pointing to this root node. I'll check that particular position A means 0. 0th index is equal to null. No, it is not null. So I'll just come to this node, and what I'll do, I'll just increase the frequency. Frequency was initially 1, and now it is 2. Now again I'll go to the next character, next is B. So now I'm pointing here actually. So I'll actually check that B index means first index is actually null or not. Yes, it is not null. So I'll come here. Now I'll point here and I increase the frequency by 1. It will be 2 now. Now again I will go next character is C. Now I'll check under this node, is there any child node? at index 2, yes, it is already present. So I'll come here and increase the frequency by 1, it will be now 2. Now next character our actually D. So I'll check under this node, for this node, is there any node at index 4? I'll check, okay, there is no actually node, it is null. So I'll create a new node. Okay, I have created this, and CP is equal to 0. And I'll now come to this node, and I'll point this, I'll increase the frequency as 1 by 1, right? Because I have already seen this once. Now you can say that I have already processed the input string ABCD. Now I have already processed all the input string now, right? So this is actually our try actually look like now. Now I'm calling this function, this all prefix. This will return the sum of all the scores for the one input string. So I'll get actually one input string ABC first time. Okay. So for each character again, initially object is pointing to the root again. Okay. Now I'll check for each character. Again, I'll come to this. I'll check what is the frequency. I'll first point to that. Now our character is A. So I'll search. I'll go to the actually node for A, like 0 index. I will go. You can check object will now point to that particular 0th index, right? Now I'll check what is the frequency of that. Frequency of that is actually 2. So I'll increase sum is actually initially 0. I'll add this into a sum, means score. Now our actually next strategy B. Again I will come to this for loop B. I'll go to the actually node for B. I'll come here. Now I'll check what is the frequency of this. Again 2. I'll add actually 2 plus 2. Now again for the go to the next character. Next character is C. So I'll search for the C. This is for C actually. What is the frequency of this? 2. So I've completed the iteration, the word. Now you can say ultimately sum value is 6. I'll return this and I'll store this into the vector A. Got it? Now we'll come to the ABCD. Again I start from the root. I'll go to the actually node A, node for A. I'll check what is the frequency of this? 2. Next I'll go to the node for B. I'll come here. What is the frequency of this? 2. Next go to the actually node for C. This actually again frequency is 2. Next go to the node for D. I'll come here actually here D. What is the frequency of this? 1. This is 7 ultimately, and I have also completed the iteration of character for inputs word, and ultimately return sum, and sum ultimately is 7. I'll store this into the vector A, and all the inputs word actually I've processed, and the return vector, it will return 6, 7. Right? Got it? Understood? Is it clear? So if it is clear, then please like the video again, and please subscribe the channel. Thank you.